Hello, let us look at the division algorithm of polynomials. Sounds complex, but it's pretty simple. We did Euclid division lemma in one of our previous videos, and what does it say? It says there is a dividend, and then there is a divisor, there is a quotient, and there is a remainder. Now, this same concept applies to division algorithm of polynomials. So we did it for numbers. For example, 7 you divided by 3, 3 2 is 6, and the remainder was 1. 2 was the quotient, 7 was the dividend, 3 was the divisor. The same concept we will apply to polynomials and see are there any differences. Let's straightway jump to example number 6, which says you have a polynomial, you divide with another polynomial. Let us try dividing and see how do we actually divide the polynomial. 2x squared plus 3x plus 1. Let us see the methodology. If this is x, you want to eliminate this 2x squared. What you need is, you need to multiply here in the quotient a number which should exactly be 2x squared. So what should you multiply with x? If you multiply 2x here, so then it will be 2x into x plus 2. 2x into x plus 2, and what is that? 2x square plus 4x. Do I write that here? 2x square plus 4x. Why did we do that? Because while dividing, we want to start eliminating terms. So the first thing what we did is from left to right. So left to right, we started eliminating the terms. So I subtract. So I eliminated 2x square and 2x square. Why? Because this is plus and this is minus. I subtracted. So what did I get? I got minus x perfect. Now as a methodology, what happens is, you bring this one down. Only one term is that you get down always. So you got down. Okay. Now what do you multiply with this x plus 2? And you have to ensure that if you multiply with whatever value in the quotient, it should exactly be, the first term of that should be equal to x. So for example, x plus 2. Can you multiply that with minus 1? Will that give you minus x minus 2? Is that perfect? Why? Because you just need exactly the first term once you multiply. So I multiply that with minus 1. So if I multiply this with minus 1 with x plus 2, this is what we get, minus x minus 2. Why did I do that? I did because I wanted to make sure that the first term is minus x. Now I subtract both the terms. So once I subtract, this minus becomes plus and this plus becomes minus. This, now I subtract. Both the terms. So what happens? This minus becomes plus and this plus. This minus becomes plus and this all minus also becomes plus. So this minus x became plus x, gets cancelled with minus x, and what we are left with 3. So what does it tell us? It tells us that remainder is 3, the quotient is 2x minus 1, the divisor is x plus 2, and this, the whole thing, is the dividend. So what did we see in Euclid division lemma? The same thing. We said the dividend is equal to divisor into the quotient plus remainder Okay, so what does the example 7 read? It says you have a polynomial 3x cubed plus x square plus 2x plus 5. You have to divide with x square plus 2x plus 1. What's our objective here? The first term has to be 3x cubed. So whatever you multiply here, let's say if I take 3x and multiply with this divisor. So 3x when I multiply with x square plus 2x plus 1, what do I get? I get exactly this, which is 3x cubed plus 6x square plus 3x. Why did I do it? Because I wanted to make sure that the first term is same to what is the first term here after multiplying. So I subtract both of them. So this becomes minus, this becomes minus, and this becomes minus. So this whole plus sign goes away, right? It just goes away. Let's forget it. It becomes minus. So this gets cancelled with this. So the answer is 0 here. Minus 6x square with plus x square becomes minus 5x square. Minus 3x with 2x will become minus x. Okay. Now what did we say? Once you found this out, just drop one term down. Plus 5. Now what you need is you need to multiply here with something so that you get minus 5x square, right? So you have, okay, so you have x square plus 2x plus 1. You have to multiply with something so that you get answer as minus 5x square as the first term. Can I say that I'll multiply that with minus 5? Because the moment I multiply this with minus 5, I'll get minus 5x square minus 10x minus 5. I need not bother what are the other terms, but I'm more concerned with the first term. So I multiply this whole term divisor with minus 5 and I get minus 5x square minus 10x minus 5. What did I do? I did it deliberately because the first term has to match, and then I subtract. So this becomes plus. I subtract, which means this whole thing gets multiplied with minus 1. So this becomes minus sign becomes plus. This minus sign becomes plus, and this minus sign becomes plus. So this becomes 0. This becomes 9x. Why? Because 10x and minus x, and this becomes 10. So can we divide it further? No. Why would that be? Because this is 9x, right? And here it is x square. You see that the power of x here is 1 and the power of x here is 2 in the divisor. The moment your remainder goes, the power of the remainder goes below the power of the divisor, you just can't multiply. What's the reason? See, you have x square plus 2x plus 1. Now you cannot multiply this with 1 also. Why? Because then that will become x square. X square plus 2x plus 1. You can't subtract. Why? Because your first term has to be 9x. And your first term is coming to as x square with a higher power. You can't do this. This is not acceptable. So when the power of the remainder, x raised to 1 is the power here, goes lower than the power of remainder here, you technically cannot divide any further. You are done. It's closed. So this becomes the remainder, 9x plus 10. This becomes the dividend. This becomes the divisor. Dividend. And this becomes the divisor. So what do we understand here? Now there are some funny notations here. So assume that the dividend, there are some funny notations here. Assume that the dividend so this is the remainder. This is the dividend. This is the quotient. This is the divisor. Right? Now, it's funny, but okay, sometimes they refer this dividend polynomial as px. They refer quotient as qx. Why? Because it's a polynomial, right? 3x minus 5. And the divisor as gx. And the remainder as rx. So what can we say by Euclid division lemma, right? We know that dividend px is equal to divisor into quotient right? So gx into qx plus r of x. But did we notice one thing, that the power of r here was x was 1 and here it was 2 and we could not divide any further. Can I also conclude that the degree of my remainder, which is rx, is always less than the degree of gx? We notice this, right? X raised to 1 and this is x raised to 2. What does this tell us? It tells us that degree of remainder will be less than the degree of the divisor. Or I can also say that there could be a possibility that the remainder can be equal to 0. I don't want to complicate it. But for example, 7 were to divide with 3. So 3 2s are 6 and the remainder was 1. Right? But if you were to divide 6 with 2, then you had 6 and the remainder was 0. This is what I am talking about. The remainder can be equal to 0, or the degree of the remainder, which is this degree 1, is always less than the degree of the divisor. This is nothing but the division algorithm. It's division algorithm. Okay, so they are saying that divide this polynomial with this polynomial. Let us try dividing. But can we rearrange the term with the higher power first? So can I write, instead of this, I can write minus x cube plus 3x square minus 3x plus 5. Can I say that? Can I divide now with my divisor, which is this? Can I also rearrange, and how the rearrange will look like? It will be minus x square plus x minus 1. Will it look like this? This one? Yes. So it will be minus x square plus x minus 1. Absolutely. Now let's start dividing. What's the basics? We start from left to right. Which is the first term? Minus x cube. You have to multiply something in the quotient. Of course, the quotient is on the top. You have to multiply the first term here should be such that you get minus x cube. So can I say that I multiply with x? Why? Because the moment I multiply this with x, with this entire divisor, can I say that minus x square plus x minus 1 you multiply with x? What is the answer here? That will be minus x cube plus x square minus x. Let's subtract. So this becomes plus, this becomes minus, and this becomes plus. This gets cancelled and becomes 0. This becomes 2x square, and 3 minus 3x and plus x becomes minus 2x. Okay. What we do is we drop this term down. Always we drop just one term always down once we are done with whole subtraction. We drop it here. Okay. Now we are left with this and we have to now solve. How do we solve? Now you multiply in the quotient such that you should get 2x square. What's your divisor? Minus x square plus x minus 1. Can I say that I will multiply this with minus 2? Why would that be? Because the moment I say that we will multiply with minus 2, can I get this as 2x square minus 2x plus 2? Let's subtract. Now this becomes minus, this becomes plus sign, and this becomes minus, because I am subtracting both of them. So this becomes 0, this becomes 0, and this becomes 3. 3 as the remainder, x minus 2 as the quotient, this as the divisor, and this whole thing as the dividend. Okay, so they are saying that we are given a polynomial which is 2x raised to 4 minus 3x cube minus 3x square plus 6x minus 2. And you have to find all the zeros. What does zeros mean? Zeros means roots. For a polynomial with degree 4, how many roots at max can it have? 4 roots. So we know first thing here. At max it can have 4 roots. Or we can say 4 zeros. Yeah? Out of which we are given second step. We know that 2 zeros are root 2 and minus root 2. Okay. Let me quickly jump to one of the quadratic equation and make your life simple. Okay, so look at this quadratic equation, x square plus 6x plus 5. Can I get two factors here, x plus 5 into x plus 1? How do you get that? You split 5 into two factors, which is 5 into 1, such that the multiplication is 5 and the addition of 5 and 1 is 6, which we are getting. Can I say that the roots or the zeros are minus 5 and minus 1? These are the roots. This is just another example, right? So just ignore the above example. We'll just see what does root mean. So we know that roots or zeros. Does this resonate with the zeros given here? Absolutely. So once we are given zeros here, can we go back and we say which were the factors here? Once they tell us that minus 5 is a 0, we know that x plus 5 is a factor. Why? Because the moment they say that minus 5 is a root or a 0, you say that x is equal to minus 5. The moment you see x is equal to minus 5, you say that x plus 5 is equal to 0. Why? Because you take minus 5 on this side. That's how you get it. Okay. Similar analogy. Now let's go to step 2. Okay, so we saw now the analogy of a quadratic equation. So can we say that the two roots here are x is equal to root 2 and x is equal to minus root 2? So can we say that which are the factors here? X minus root 2 is equal to 0. Why? Because I take root 2 on the other side and I'd say x plus root 2 is equal to 0. Then what's the quadratic equation we get from this? So we get, if you multiply both of them, x minus root 2 and x plus root 2, what do you get? You get x square minus 2. Okay. You know that this is the equation if you had these two as the zeros. Can I say that if 2x raised to 4 minus 3x cube minus 3x square plus 6x minus 2. What are the zeros here? Root 2 and minus root 2. So what are the factors? X minus root 2 and x plus root 2. What does it mean? It means that if these are the zeros, the whole polynomial above is divisible by these two factors. So can I also say that the polynomial is also divisible by this, which is x square minus 2? Why? Because it is nothing but the product of both, right? So let us now divide. X square minus 2. Okay, so we need to get 2x raised to 4. So can I say that I will multiply with 2x square here? Absolutely. So I'll get 2x raised to 4 minus 4x square. Is it fair enough? Because I multiplied 2x square with x square minus 2. Okay, brilliant. Now let's subtract. So this gets cancelled and this becomes. Now can you add a 3 minus 3x cube and 4x square? You cannot. Why? Because the powers are different. They don't look same, right? You can only add similar terms or subtract. So this becomes minus 3x cube. So what happens is this becomes minus 4x square. Why? Because, this becomes plus 4x square because the 4x square comes down. And now what you do is you take one term down. So that becomes minus 3x square. This term comes down. So effectively plus 4x square minus 3x square. Can I write both the terms as only x square? So I'll write this term as only x square. Why? Because this is, I got minus 3x square down and that was plus 4x square. Okay. Now let me multiply this with something so that this becomes minus 3x cube minus 3x. So that becomes minus 3x cube plus 6x. I'll subtract both of them. Okay, so what happens now? Now we say that okay, this x square comes down. Why? Because this gets cancelled here. X square minus 6x. Okay, this is done. So now we get this 6x down. So this becomes plus 6x. Okay, that gets cancelled. Okay, now we are left with only x square. If you need to get only x square, don't get 2 down now. Wait. Now you need to multiply this with plus 1. Why would that be? Because you need only x square here. So that will be x square minus 2. Right? You need to subtract both of them. So this becomes plus 2. This gets cancelled. This becomes plus 2. You get this 2 down. And that is minus 2. Plus 2 and minus 2, 0. And hence your remainder is 0. So now they are asking you find all the zeros of the equation. So okay, you know that 2 zeros come from this, right? So naturally the other zero should come from the 2x square minus 3x plus 1 is equal to 0. Should be another equation. And once you solve this, which is a quadratic equation, I will not go into much of depth of solving it. But you will get the answer as x is equal to 1 and x is equal to minus, x is equal to half. So which are the zeros here? You get these 2 zeros marked in star and these 2 zeros which are already given to you. So you have 4 zeros which you got it. I hope you got the concept here.